Let's go. What is the definition of nature? Definition of nature is God's creation. Okay. Then what's the definition of science? Science is the knowledge that explains nature, or you can say discovery of nature is science. Okay, science, discovery of nature of science. So what is engineering? Engineering is the utilization of science to create a device. Okay. So God created nature, and then like a Newton find the nature. So like a gravity law and find the nature. And if engineer use the gravity law, create some tool. Okay, that's engineering. Utilization of science to create a device. Okay, so all the scientific theory is a base for engineering work. There's no engineering work without a scientific base. So you have to learn science. You have to learn math because that's the foundation for the good engineering work. Then application. So how do you put all device together for a product? That's called application. Okay. So I will show you later. So nature is God's creation, science discovery of nature, engineering is utilization of science, application is putting together, put all engineer effort together as a product. In Genesis, everybody know, and God said, let there be light, and there was light. And God looking on the light, saw that it was good, and God made a division between the light and the dark. So naming the light day and the dark the night. And there was evening and there was morning at the first day. So during the God's creation, it said the sixth time, there was evening and there's one morning. But God didn't say this was morning and there was evening. God said it was evening and the morning. And the Bible didn't say it was night and day. It said evening and the morning. So the evening and the morning is because the whole world started as a dark first, and God created light. Is that right? So darkness is the first, light is the second. So maybe start from evening and there's morning. Now what's the difference between the evening and the night, the morning and the day? Night and day is effects, the dark and the bright. But evening is gradually getting dark, and morning is gradually become bright, become light. So you can see the ing at the both evening and the morning. What does that mean? It means it's progressive, right? Progressive things. So evening and the morning. Now here comes the fun part. Now I'm going to talk about it. So God created light. So I'm going to talk about product today for you. Camera and television. Everybody had the smartphone, had the camera, right? And everybody watching TV all the time. I want to tell you some fundamental theory, okay, about the camera and the television. So start with God's creation. Science had to discover the nature. So God created the light. What's in the light? What's in the light? So the science about the light, okay, scientists find out light has three primary colors. Everybody knows, I guess. Three primary colors called red color, green color, and blue color. That's how the God created light, is that right? Red, green, and the blue. Then combination of this so-called three primary color can create a million of different colors. It depends on the combination of the degree of red, degree of green, and degree of blue, and mix together a different kind of combination. So you can see blue and red create this like a purple, a magenta, okay, magenta, and the red and green, yellow, and green and blue, cyan, and all together is white. So when we see the bright light, actually it's red, green, and blue together, bright white light. But even the white light, you know, have a different kind of white light. A very white, a creamy white, all kind of white, right? Because a different degree of the red, green, blue. And because these three primary colors, you can create the millions of colors. And this is just some example. So this is why HD TV is so beautiful, because HD TV captures the nature, and nature have a million of different colors. Okay, millions of different colors. So camera is trying to catch all the color, and television is trying to display all the color. Any image is combination of different color. Am I right? Any image combination of different color. So camera is trying to catch all the different color pattern, and the television trying to display the same thing camera has caught. Now come to engineering. Remember, engineering tried to utilize the science to create some device. So you can see this RGB here. There are RGB, 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 because every color is combination of different degree of RGB. So actually, in the television on your right-hand side, okay, the television, you can see RGB, 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 LED. So when you see very closely, they are arranged like that. But when you see very far, all you can see the combination of the color. Okay, so for every RGB, we call one pixel. Okay, so maybe like this 3 is like 1 pixel, or this 4 is more like a 1 pixel, 1 pixel, 1 pixel. So when you see the camera say the 10 million pixel, 20 million pixel resolution, what does that mean? That means it's a small camera. They can divide the image into 20 million small pixel. Okay, so it's like a HD TV. HD TV is probably like a 2 million pixel. Okay, it's 1920 times 1080 pixel. So it's like 2 million RGB pixel, 2 million RGB pixel. So when the RGB have different color combination, they can see all the different image, different color. So this is called HD TV. Is there any question? Just trying to make sure this basic is understood. Any question? You can type into the WeChat, chat room, I say. Bigger monitor doesn't necessarily have more pixel. Okay, doesn't necessary. Like HD TV is the same standard. HD TV is the same standard, so they have the same amount of resolution. Okay, same amount of resolution. But however, bigger TV, when you get closer, it's easy to see all those pixels. Right? Because pixels are bigger. But small TV, it's hard to see the big pixel. So they have a right distance. Okay, that's called the aspect ratio. For bigger TV, you need to stay farther to watch it. For small monitor, you can stay closer to watch it. But if a very huge TV, you stay closer and you start seeing the pixel. Okay, and then you feel it's good. Yeah, I think somebody really know what's going on here. Okay. Any more questions? Just let me know. So once you understand this basic component for the television, the camera, and then it's easy to understand how the engineering works now. Image sensor. For every camera, you need to capture the picture, you need to capture the light, you need to capture the color. You have to have the so-called image sensor. Okay. The image sensor in the camera is very small, very tiny. You look at the iPhone camera, that's 3 lens or 2 lens, very small, and behind the lens is an image sensor. So the light goes through the lens and shine on the image sensor. Now, every image sensor again have 1 pixel. called RGB, okay, RGB pixel. So for the RGB pixel, and of course, you need a kind of a filter to decide, okay, which color coming in, which color doesn't come in, all right. For the green, they let the green color come in. For the blue, they let the blue color come in. And the red, they let the red color come in. So they decompose all the light into the RGB, and then they can compose it back on the television. So you see exactly the same thing. So image sensor is more like arranged like that. And each dot, that's not pixel. 3 color from 1 pixel, each dot, there's a filter. So the light coming in, they filter all the RGB, and then they can recombine together and project on the LED display. Okay, this is called the image sensor. Very tiny. The engineering work is amazing. It's one tiny image sensor has like a iPhone have a 12 million pixel. iPhone has 12 million pixel. Okay, and then the best digital camera has 20 million to 40 million pixel. That means with tiny semiconductor device like a chip, like my thumbnail, they have a 40 million tiny sensor cell there. The light shining on the sensor cell, and each pixel, each dot, record the light intensity. Then become red, blue, green. Okay. So far, any question? Okay. So somebody very interesting called a photoresistor. This is a photo sensor. Okay. Photo sensor is very top technology, and the people keep improving it because you have to catch the light, then convert the light into the electric signal. Then electric signal can convert into the digital signal, so computer can do something about it. So this is image sensor. So there is this kind of image sensor behind every lens of the camera. Okay, behind every lens of camera. Here we go, the next one. You see this image sensor. Okay, this is image sensor. And for the digital camera, this image sensor has 20 to 40 million dots in there. 20 to 40 million dots in there. So if the light shine on it, if a red color shine on this red color spot, blue color, blue spot. Okay, if it's an image, like my picture on it, then of course, every part of my image is decomposed into the RGB. Okay, so this is an image sensor device. I always think about why there's so many, we call the pin, okay, connection go to the outside, because it's a very complicated engineering device. In order to capture the light, there's a lot of, we call the signal processing in there. You have to catch it, you have to convert it into the signal and send to the computer. So this sensor itself only take care of capturing the image and then convert all the image into the digital signal. We call it digital signal, 1 and 0, 1 and 0 for the computer to process it. Okay, for the computer to process it. So that's called digital signal because computer doesn't have the analog signal. All the signal God created, we call the analog signal. What does that mean? Like it means unlimited resolution. So if I can speak louder, a little bit softer, it's unlimited strength of the signal. That's called analog signal. So the light can be very bright, a little bit brighter, a little bit darker, a little bit dimmer. It's unlimited resolution. But however, the computer cannot handle the signal. Computer can only do 1 and 0, 1 and 0. So between the digital signal and the analog signal, there need to be a conversion. Okay. In the future, I can If you're interested, I can talk to you more. Okay, any question? Transistor processing, different mode RGB light. Yeah, they call transistor processing. The bottom line is a device that can handle the light image sensing. Then what's the next? Let me show you what the camera really looks like. Very simple, actually very simple. You have an image with all the color and goes through the lens and then project into the sensor. The sensor I just showed you. Okay, the sensor, RGB sensor. Then they have a lot of dots. Okay, all these dots become a digital signal and then can transfer to the computer. So this is just the capturing of the image. Am I right? Capturing of the image, then convert into the 1 and 0 digital signal. Then you can store it. How do they store it? Everybody know you store it into the USB stick, or they call it SD card. So basically, every camera, you have a memory storage card. They store all the image. And then you can take this data and go to the, well, every camera have a display, remember? And then you can convert this data into the display to show it here, okay? Or into the big television. They can show on the television. When you have a HDMI cable, that's what they did. They just grab the image storage data and display on the big HD TV. That's what that's a HDMI cable do. Okay, just take the digital signal and put in every dot. So basically, you just bit-to-bit mapping of the sensor image to the display image. And then remember, the reason you can see it, what did you catch, is because they convert image sensor data into digital, and digital convert back to show on the display. Okay, this is a color display. So this exactly what the image sensor have to capture, and then they display on this, we call this is the LCD display, exactly color. So this actually have like maybe 10 million pixel, okay, because maybe even less, like 2 million pixel on the camera display, only 2 million pixel. There's interesting part coming in now. How do we see? You know, the camera can see and can display. And what does human do? What's a human being? How does human being see? Exactly the same thing. That's what funny part. That's what's interesting about it. It's exactly the same thing. We have a lens. Okay? We have a lens. I did a cataract removal at the end of 2019 because my lens had the cataract. Make my vision.
And it is stretchable.
I'm sorry?
It's also stretchable.
Yeah, it's very flexible.
So
okay.
Instead of moving it back and forth like a camera does, it just sort of stretches the lens different amounts.
Actually, there's a lot of theory in here. Okay, the eye is amazing. Just like the lens can go front and you can focus. It's the reason it stretches because you can see clear, you can see near, or you can see far. Okay, that's why the lens is flexible. You're very smart. You're right. The lens is flexible. In the camera, the lens can be moved back and forth, back and forth. Okay, so they can see the clear and the close and far, close and the far. And that's the optical theory. In the future, you can study more. Okay, that's why remember the focus lens, you can rotate it and you can make the image clear on the screen. Okay, and that's exactly what the human eyes do. But God created human eyes with a flexible lens and the clear transparent lens when you're young. And we're getting older because this protein start getting a little bit cataract in there and block the light. And then just focus on the 3 red arrow, the lens coming in. And then what is this? Retina. What is retina? Retina is the same thing like this image sensor. Okay, the same thing like this image sensor. But human being created this through all the science, engineering work. But God created our retina naturally. It's just, every part of organ started from one stem cell, right? One stem cell. How does such a complicated image sensor, we call the natural image sensor God gave to us, it's called retina. Okay, retina. And then all the retina information converting to the electronic signal. It's also electronic signal, okay. Goes through the nerves, goes through the nerve, optical nerve, and pass to the brain. So brain can process the signal. It's just like all the sensor signal, this are retina, and goes through the signal conversion and pass to the brain. Pass to the brain. Exactly the same thing. Isn't that amazing? It takes a human being, millions of people, to do something like this. Millions of people. Okay, out of trillions of dollars to create something like that. We only take God's one stem cell, create this retina, and create this flexible lens and signal coming in, and goes through the electronic, pass to the brain. Okay. And guess what? We have 2 super good cameras. Each one have how many pixels? 576 million pixels. Here, have 576 million pixels. Remember what the HGTV has? 2 million pixels. This is why it's so hard to make a good television, make people feel good, because our vision, our eye is super, super good, super, super sensitive. Our eye can see millions different colors, all kind of brightness, all kind of resolution. So human beings try very hard, but still cannot make the camera and the television very good to satisfy our eyes. Amazing, isn't it? God just used one stem cell, one tiny stem cell, created such beautiful eyes. And human beings try many, many years, $1 trillion effort, still couldn't make the perfect image processing, image display tool for us. Of course, get better and better. And this is what's the amazing part of. And then, of course, this retina had to be supplied by all the blood vessels, okay, to make sure this retina can survive, can constantly get nutrition, constantly get sensitive signal. And then if you eat enough vitamin A, and this retina can be more sensitive. But if you don't have enough vitamin A, the sensitivity of the retina can get worse. That's why the nutrition is very important for this God created image sensor. God created image sensor. The eye is a perfect, okay, perfect engineering work. I call it engineering work. Even it's God's creation, but still God is a super engineer. Then this light comes through the lens. They have to go through a part of liquid. We call it virtuous, okay, virtuous. And this liquid had to be pure crystal clear. So sometimes if you have a floater, you can see the floater sometimes inside, and then you can feel like it's there and block a little bit of image. It's amazing how God's created your eyes, okay? Remember this number, we have 576 million pixels. And you have to take good care of your eyes because you don't see it and you can cause a lot of trouble for your life. Then what's interesting coming in now. And this is where the mystery part coming in. And now I want to ask you to see anybody have any answer at all. Okay. So you see something. Okay. You see something. You both eyes see something. Why do we need two eyes? Because it make a 3D. So because you can see the depths. Okay. Different angle. See the depths. Okay. The eyes see the same object, but because there's an angle information, when you pass to the brain can say it's close, it's far. So we become a 3D. Okay, we can see 3D. Camera is 2D. So camera is never good enough for eyes. You see it, then what happened? The image projected on the retina, and somehow all the image converted into the signal in sequence, pass to the optical nerve, pass to the nerve. And the nerve passes signal to the brain. And brain processes the signal. And then you can see the same thing. The B you see, and the brain perceive. So the eye sees called the sensation. I sense it. And the brain processing it. And you see it in the brain called perception. Okay. Remember, in the camera, the reason you can see is because you have a screen to show what you captured there. Right? On this, you cannot see the picture. It just sends a signal. You cannot see the picture. But you have to have a display to convert this information into the display so we can see it. Now, question coming in now. The mystery is this. Are you ready for the mystery? See whether you have the answer. In our brain, do we have a display there? No, we don't have a display. And how do you see? Anybody can guess anything. How do you see? I say 20 bonus point. How do you see? Some people say the optical nerve in front of the retina. Wow, somebody's really good. Retina use opsin protein. Okay, so I just take it from the, okay, I just take it from the Google search. Okay, so I would expect they know what they're talking about. Okay, the nerve is behind the retina or in front of the retina, I don't know. Yeah, but I do know all the optical nerve have to pass through the behind the retina, go to the brain, because no other ways you can go to the brain. Okay, let me read more about the chat.
It's behind.
It's behind. Okay, yeah, that's what I thought. Okay.
Because I half of my career of anesthesia, I was doing retina surgery. So
oh, okay. That's a retina surgery.
Just information. You would think that a lot of bright people go into medicines, but the brightest of the brightest goes into retina surgery. Yeah. And,
yeah.
And I mean, the retina surgeons. I'm only the anesthesiologist. I only put a needle in and numb up the eye for the surgeon to operate on.
Yeah, my daughter had a retina detachment once, very young age. So they had to cut their eyes open and put the retina back against the wall. Okay, so you had to be careful. Whenever you see the flashing light in your eyes, you need to go to the eye doctor immediately. Because once the retina detach, hurt your vision. Okay, that's what happened to my daughter. That's called the retina detachment. They detach from the wall. They had to cut the eyeball open and push it back. That's a tough process. So now, go back to my mystery. Question about mystery. How God make us see. You can pass a signal into the brain. The brain doesn't have the LCD display, doesn't have the LED display, doesn't have no display. It's just a bunch of protein, Nara. It's just a bunch of protein. We already say 100 billion neuron cells. And some part of it process the video signal. So how do we see? Anybody have any idea? How do we see? Nathan, wow, Nathan's good. Nathan, which grade are you in? Nathan Song. Nathan, you can open your mic and please respond. Which grade are you in?
I keep forgetting my grade.
I'm sorry?
I keep forgetting my grade because I'm homeschooled. So there aren't any like homeworks that
I should say,
grade what?
how old are you? How old are you? I'm sorry.
10.
Oh, you're so smart. Look at that. You love to study this science stuff, huh? You love to understand the body.
Yeah, I got the biology textbook.
Awesome, awesome. It's very good. So Nathan studied a lot about eyes and a lot of this terminology there. Wow. Pastor Lee must be pretty impressed by Nathan's chat here. Okay. He had all the terminology, acronym here. Awesome.
He copy and paste somewhere. That's good. That's
okay. So the perception. Let me give you another example about sensation perception. When you use hand to touch the hot stuff, of course, you have a sensor signal on our hand, on the skin. Then it passes a sensor signal and to the brain. So if you get burned, you say, oh, hurt, it's so painful. And then however, if like the Dr. Lee's anesthesiologist, he can inject a chemical into your body and block the signal transferring to the brain, and you don't feel pain at all. So sensation is responsible for passing the signal, but the brain is responsible for make you feel pain. And that's called perception, okay, perception. And so if you get cut on your hands very big, you feel extremely painful. What does that mean? It's just a signal, tiny, tiny, tiny electronic signal pass through the brain. It just gets a little bit stronger, okay? Those signals so small, you cannot even measure it in our engineering equipment. But however, your brain can say, oh, it's so painful, I want to die.
It's multiple signals.
Multiple signals.
A lot of signals.
Yeah, a lot of signal. But what makes you so painful? Where's the energy come from? What makes you so painful? What makes you see this picture? What makes you hear the music? So sensation, it just retrieve the signal. Perception's in charge of what God wants you to see, what God wants you to hear, and what God wants you to feel. This is called perception. The answer is nobody knows. Okay, nobody in this world knows how God makes us see in the brain, how God makes us feel in the brain. We know which part of the brain is in charge of the visual, in charge of audio, in charge of feeling, in charge of understanding. But however, we don't know how it really makes us perceive. And this is why it called perception is reality. But how God really makes us see something. Another interesting part of it is called the cognition recognition. So the moment you see it, the first time you see it, you cognize it. You know it, you understand it as a fact. The second time you see it, you say, I recognize it, recognize it. That's called recognition. Because I see it again. And it's already in my memory. I know what happened. Same thing, you touch it first time, you don't know it burned. But second time, after you recognize it, you don't touch it because you had a memory. You have remember all this called recognition. And then another mystery part of it, I like you think about it, we call appreciation. So if I see this beautiful flower here, and then my brain said, wow, it's beautiful. So my brain somehow perceive the signal and make a decision, say it's beautiful. In order for my brain to say it's beautiful, I have to compare with the standard MRI. It can be ugly, it can be beautiful. But what make my standard stay there? And then I make the decision, say it's beautiful. And this is what I want to tell you, how God created you and me. Why we're God's son and daughter, why we're God's children. Because God is God is the best artist in the whole universe. So he make a lot of beautiful flowers, or creature or animal. And then he created the eyes for us to see what he created, the beautiful nature he created. Then he put a standard of the beautiful into our brain. Then after we see it, we perceive it, and we say it's beautiful. The nature is so beautiful. Then we start appreciate God's creation. And God is happy, say, good, my children can see my glory. Let's close the loop. My children can see my glory. Think about how much effort God had to put in for his children to appreciate his creation. The first thing, God's artist, create a lot of flower, the mountain, everything. And then God gave us two perfect eyes. Each eye have a 576 million pixel. So we can process it, and we can see it, we can perceive it in the brain. Then we can compare what we see with the God-given standard. Then we come out and say, oh, it's beautiful. It's a very complicated process, but God made it happen in a single, starting from a single stem cell, in a single stem cell. And so much we still don't understand how God is communicating to us so we can perceive it and we can appreciate it. And this is where the mystery is. And unless someday we go to heaven, I don't think we have the answer. There's a question, how do people know it is 560 million pixel? I think it went through some scientific analysis. Okay, went through some scientific analysis. They created different kind of resolution display and want to see the people's eyes, how can they catch it, and eventually find the detail. Well, however, I have to say one thing. The center part of the retina is the most important thing. This is called the focus vision part. The other called the peripheral vision. Peripheral, you can see the thickness different. Peripheral vision doesn't have that much resolution, but center part is the most important part because most of the reading, everything is come right into the center part. That's called the macula. Macula gives a much more resolution than the peripheral part. Peripheral, you don't see much detail. You just know something's there. But the center macular part is the most important part. Okay. Mm-hmm. Okay, yeah. So I think I give you the whole story. And let me go over again pretty quick. God created the light. And the light have a 3 primary color. Combination of 3 primary color and become all the image element. And this is called science. Human beings find out what the light is all about. And they have a million of color. And then the engineering people to take advantage of scientific theory to create a sensor, create a display, and then we'll create a camera, digital camera, then we'll create HD TV, and we can see, we can do a lot of things with it and keep improving, okay? And then we know God created our eyes is even better than all the camera can do, okay? We have 576 million pixels. This is what I found from the Google. And then God give us sensation.
There's those 3 primary colors are only for people. For different animals, there's different primary colors.
Yeah, right.
So actually, there's a whole range of different frequencies of light.
Yeah, you're right. Nathan's pretty good. Nathan definitely can be a good scientist or engineer. Okay, so what Nathan says is right. Okay, for some animal like cow can only see gray color. So that's why I say human being is a children of God, because only human being can appreciate the beautiful flower and smell the aroma of the flower. Have you seen a group of monkeys gather around the beautiful flower, say, "Wow, look at the flower, so beautiful." You never seen the dog keep smelling, "Wow, this flower is so good." No, because only human being had the capability to appreciate God's creation, because God wants the human being understand his glory. This is why God created us for his glory. Remember last time I say, God created us for his glory. And we're the only one can appreciate his glory. Then we don't have the capability to appreciate his glory unless God put that capability in our brain.